Hello. With this video, we begin our unit on acid-base chemistry. We will start with chapter 14.1 on properties of acids and bases. First, let's ask the question, what is an acid? An acid is a solute that dissolves in water to form an aqueous solution that has the following properties. Number one, it tastes sour, that is, if it's safe to taste. Number two, it changes the color of certain molecules called indicators. And as we'll see later in the unit, acid-base indicators are molecules that change their color depending upon the acidity or basicity of the solution. Acids react with metals to form, among other things, hydrogen gas is one of the products. Acids react with molecules called bases, which we'll talk about in a moment, to form two products, water and a salt, in a process called a neutralization reaction. And finally, acids form solutions that conduct electric current. And we all know what we call a solute that forms an aqueous solution that conducts an electric current. Yes, it is called an electrolyte. So acids are electrolytes. Here are some examples of things you might find around your house that contain acids. Citrus fruits contain a molecule called citric acid. Vinegar contains a molecule called acetic acid. And car batteries contain sulfuric acid. Now, let's talk about a system for naming acids given the formula in a process you know is called nomenclature. We will group all of our acids into two categories, binary acids and oxyacids, and we'll consider each of these sequentially. First, a binary acid, as its name implies, is a binary compound, meaning it contains two elements. One of those elements is hydrogen, and the other element, which we'll represent as X, is almost always a nonmetallic element. The formula of a binary acid will simply contain the elements hydrogen and X, and there are always either one or two hydrogen atoms per atom of element X. The formula for naming a binary acid looks like this. It's two words. The first word begins with the prefix hydro, followed by the root of the name of element X, with the suffix -ic, followed by the word acid. So, hydro, element root, -ic, acid. Let's do an example. If I give you the formula HCl, you recognize that the other element X is chlorine. The root of the name of the element chlorine is chlor, so we will call this hydrochloric acid, which we're familiar with. Likewise, HBr contains the element bromine. The root of the name of the element is brome, so we will call this hydrobromic acid. Oxyacids, on the other hand, are a little bit more complicated. They're not binary compounds. An oxyacid contains one or more hydrogen cations, H+, and an oxyanion, which is simply a polyatomic anion that contains oxygen. Where do we find polyatomic anions? Well, on the nomenclature sheet, of course. Now, to name an oxyacid, we first have to identify and name the oxyanion that's contained within the acid. And if the name of the oxyanion ends in "ite," we name the acid by taking the root of the name of the oxyanion, adding the suffix "us," O-U-S, followed by the word acid. On the other hand, if the name of the oxyanion ends in "ate," then we name the acid by taking the root of the name of the oxyanion, adding the suffix "ic," followed by the word acid. So ite anions form us acids, ic anions form ate acids. Sorry, ate anions form ic acids. Now, let's do some examples. If I give you the formula HNO2, I expect you to recognize that that is an oxyanion that contains one hydrogen cation, H+, plus the polyatomic anion NO2-. Simple charge balance. The name of the oxyanion we find by looking on the nomenclature sheet, and NO2- is the nitrite anion. Because it is an ite anion, it forms an us acid, so we will simply name it as nitrous acid by taking the root of the name of the oxyanion, nitrite. Let's do another example in the opposite direction. If I give you the name sulfuric acid, you recognize that because it is an ic acid, it must contain an ate anion, and that ate anion must be based on the root sulfur, So that would be the sulfate anion. And we know from the nomenclature sheet that the sulfate anion has the formula SO4 with the 2 negative charge. So to come up with the formula, we add enough hydrogen ions, enough H plus cations, to neutralize the negative charge in the 8 anion. Since the sulfate anion has a 2 negative charge, that means we need 2 hydrogen ions. Therefore, the formula will be H2SO4. Okay? Now, one thing you may notice is that the names and formulas of several common acids, both binary acids and oxyacids, are on your nomenclature sheet, but you should be familiar with them anyway. However, you do need to understand these rules so that you can name acids that do not appear on the nomenclature sheet. Now let's move on to bases. What is a base? A base is also a solute that forms an aqueous solution, and here are some properties of bases. They taste bitter, that is, if it is safe to taste, of course. Bases also change the color of indicators, just like acids do. If it's safe to touch, a base normally feels slippery between your fingers, and I'll explain in class exactly why that is. As we said before, acids and bases react with one another in a neutralization process to form water and a salt. And bases also form aqueous solutions that conduct an electric current, which means that bases are also electrolytes. And here are examples of things that you might find around your house that contain bases. Soap contains bases. Drain cleaner contains a very strong base, sodium hydroxide, extremely dangerous. And household ammonia, NH3, is found in cleaning solutions. And this is all we're going to say about acids and bases for now. And in our next section, we will talk about theories or properties of acids and bases.